Hello everyone. Here we will discuss about design of control unit. So first we understand what is the control unit. Control unit is used to control any particular signal. To execute an instruction, the processor must generate control signal for data path in a proper sequence. There are two alternative approaches to generate control signal. First one is a hardwired control unit and second is a microprogram control unit. There is a one block diagram of that hardwired control unit. There is a one clock, then control step counter, step decoder, encoder, instruction decoder, instruction register. A counter is used to keep track of time step. Each step in the sequence is completed in a one clock cycle. The control signal is determined by four steps, that is content of control step counter, then content of instruction register, content of conditional code flags, and last one is an external input signal such as MFC. Let's discuss the working of hardwired control unit. The encoder or decoder. Everyone knows that what is it is a combinational circuit which can generate control signal depending on input provided. The step decoder generates separate signal line for each step in a control sequence, that is T1, T2, T3. You will be able to see T1, T2, T3 up to Tn. Among the total set of instruction, the instruction decoder is used to select one of the instruction. At every clock cycle, run signal is used to increment the counter by 1 and the end signal starts new instruction. The sequence of operation is carried out by control unit is determined by wiring of logic elements. So hence it is named as hardwired control unit. Uh, Now we understand what is the example of hardware control unit. First one is a AND R1, R2. There are six clock cycles which can execute the totally instruction T1, T2, T3 up to T6. So, in T1, PC out, MAR in, read, select 4, add, ZD. The content of program counter are placed on the bus. The content of memory from the bus loaded into the memory address register, that is MAR, and the read operation is done here. The select 4 is used to increment the value of PC by 4, and the PC is incremented by 4 in add, and after that ZDN, the result is loaded into the temporary register R2. In T2, Z out, PC in, Y in, WMFC. The value from register Z is placed into the bus and PC in, the value incremented is loaded back into the PC. The value is also loaded into the Y is a register. Wait for memory function complete. In T3, MDR out, IR in. The content of memory data register, which now holds fetched instruction, are pressed on the bus. In IR in, the fetched instruction is loaded into the instruction register. In T4 cycle, R1 out, Y in, select Y. The content of register R1 is placed on the bus and Y in is a value from R1 is loaded into the Y register and select the Y register as an input for the upcoming operation. In T5, R2 out, select Y, add Z in. The content of register R2 are placed on the bus and the Y register is selected again to be continued as the input for the addition operation, and the result of addition is loaded into the Z register. In the last cycle, Z out are in M. The result from Z register is placed on the bus and the result is loaded into the register R1 and the end shows that the operation is completed here. Then the second example is branch level. First three clock cycles are same as we seen in above example. So we start from T4, IR out, select Y, Z in. In T4, IR out. The content of instruction register which contains the address offset or a target level for the branch are placed on the bus, and in select Y, the Y register which holds the incremented PC by value from earlier. After that, add the content of IR is loaded or added into the content of Y, and the result of this addition is stored in the Z register. In the last cycle T5, Z out, PC in, Z in, end. The value from Z register, the new address, PC address after the branch calculation is placed onto that bus. And in PCN, the new PC value is loaded into the PC register, updating it to the target address of that bus. And the A is used to show that the operation is completed here. Thank you.